Assalamualaikum. Today I want to explain about integration by part. This is second technique in integrating. The first, of course, a du dx substitution. This is a very interesting because the type of product rules of derivative. So let's go to write the formula. We have a two function. First function is called u and another function is called v. And the product rules write as derivative of u times v equals u times derivative of v plus v times derivative of u. So, how to integrate? Okay, just put the symbol. Now we have integral derivative. We know whatever is inside that. So u times v equal integrate u dv plus integrate v du. Switching the around little bit, solving for integrate u dv equal uv minus integrate v du. This is a basic formula. The formula for integration by parts is the integral some function u times derivative other function is equal to the function u times an entire derivative the other function minus integral of function v times derivative of u. How to choose u and dv? First, most of the time du is simpler than u. If you choose x squared to be u, is du equal to x. Second, whatever you select for a dv, you should be able to find entire derivative v. And lastly, v should be simple than dv most of the time. Before to do examples, I want to explain a little bit about indefinite integral and definite integral. Indefinite integral and definite integral are under topic integration. What is integration? For examples, y equal 5x power of 3 minus 2x plus 9. So, dy dx equal 15x squared minus 2. This solution is differentiation. So, integration is inverse of differentiation. From this equation, dy dx equal 15x squared minus 2 to y equal 5x power of 3 minus 2x plus 9. Now, I want to explain about indefinite integral. We use same equation. Dy dx equal 15x squared minus 2. Dx move to the right. So, dy 15x squared minus 2 dx. Before that, I want to give a basic formula indefinite integral. Integral ax power of n equal integral ax power of n plus 1 over n plus 1 plus c. C is indefinite integration. So back to the equation. So integral dy equal integral 15x squared minus 2 dx. Y equal 15x power of 2 plus 1 is equal 3 over 3 minus 2x plus c. So the final answer is y equal 5x power of 3 minus 2x plus c. Definite integral. The definite integral are some concept with indefinite integral, but there are some difference. Now look the equation. Integral s squared plus 3 du. This is an indefinite integral and have plus c. So in case definite integral, put limitation 0, 1 or 1, 2 or 2, 3. A 0 is a lower and 1 is upper. So integrate x power of 3 over 3 plus 3x and transfer limitation 0, 1 and 1 over 3 plus 3 minus 0 power of 3 over 3 plus 3 times 0. And the final answer is 10 over 3. This is a difference between indefinite, and the final answer will get the value. Okay, let's go on to two examples. Integrate x e dx times derivative of x. So going to look for the function u dv. U equal to x, du equal to dx, dv equal to e dt, e dx, dx, and of course v equal to e dx. So write a formula for integral by parts. Integral some function u times derivative other function is equal to the function u times entire derivative the other function minus integral of function times derivative of u. So put the value to get answer x e dx minus integrals e dx times derivative of x. So the answer is x e dx minus e dx plus c. C is constant.
Integral by parts. Find indefinite and definite integrals of the product of two functions using integration by parts. Question number 1. Integral x to the power of n inverse sine ax dx while n is less than or equal to 2. Integral of x to the power of n inverse sine ax dx while n is less than or equal to 2. First, substitute n equal to 2 into the equation. So, we will get integral of x squared inverse sine ax dx. By using integral by parts, first, we need to choose u and dv from the equation based on lie-add order, which are L is logs function, I is inverse function, A is algebraic function, T is trigonometric function, and E is exponential function. From the equation x squared inverse sine ax dx, we let u equal to inverse sine ax, then we get du over dx is equal to 1 over square root of 1 minus ax squared times a. Bring the dx to the right side, so we get du is equal to a over square root of 1 minus x squared dx. Then, let dv equal to x squared dx. V is equal to x cubed over 3. From the formula of integral by parts, Integral u dv is equal to uv minus integral of v du. Substitute from what we get into the formula. So, integral of x squared inverse sine ax dx is equal to x cubed over 3 inverse sine ax minus integral of x cubed over 3 times a over square root of 1 minus ax squared dx. Then we get x cubed over 3 inverse sine ax minus 1 over 3 integral of ax squared times x over square root of 1 minus ax squared dx. So we need to solve the integral equation first. By using substitution, we let u equal to square root of 1 minus ax squared. Then we get u squared equal to 1 minus ax squared equal to 1 minus u squared. Then du equal to 1 over 2 times 1 over square root of 1 minus ax squared times negative 2ax dx. After we cancel 2 over 2, we get negative ax over square root of 1 minus ax squared dx. Then we need to change the sign negative to the left side. So we get du over negative a equal to x over 1 square root of 1 minus ax squared dx. After that, we need to change the equation in terms of u. So we will get integral of 1 minus u squared times negative du over a. Then we can put the constant in front of the equation. So 1 over a integral of u squared minus 1 du. Then we need to integrate u squared minus 1. So we will get 1 over a u cubed over 3 minus u. And then we need to substitute u and also u squared into the equation. So we will get 1 over a times 1 over 3 square root of 1 minus ax squared times 1 minus ax squared minus 3. Then we will simplify the equation. So we will get 1 over a times 1 over 3 square root of 1 minus ax squared negative ax squared minus 2. After that, we need to change the negative signs to the in front. So 1 over a times negative 1 over 3 times square root of 1 minus ax squared times ax squared plus 2. And then we need to times the constant. So we will get negative 1 over 3a times 1 minus ax squared times ax squared plus. So for the last step, we need to substitute the answer we get from the above. So then integral of x squared inverse sine ax dx is equal to x cubed over 3 inverse sine ax minus 1 over 3 times negative 1 over 3a square root of 1 minus ax squared times ax squared plus 2. And then after simplify the answer, we can get the last answer, which is 1 over 3 times x cubed inverse sine ax plus 1 over 3a times square root of 1 minus ax squared times ax squared plus 2 plus c. So that's the last answer.
Hi, today I want to explain about integration by parts. So the question that I got is integral x to the power of n cos inverse ax dx n is less than or equal to 2. I will use two methods. First, I will use using formula. The formula is integral u dv first, using formula. The formula is integrate u dv equal to ub minus integral v du. So, as the question is integral x to the power of n cos inverse ax dx and less than or equal to 2. So first we must find the value of u, and for integrate we will use dv over dx. So u, let's n equal to 2. So x the power of 2 dv over dx is cos inverse ax. So differentiate the du over dx equal to 2x. Integrate v equal to sin inverse ax over a. So du is equal to 2dx. V still sin inverse ax over a. Okay, so now we put the value that we have got into the formula. So integral x to the power of 2 sin inverse ax over a equal to x to the power of 2 sin inverse ax over a minus integral sin inverse ax over a multiplied by 2dx. So the answer x to the power of 2 sin inverse ax over a. So integrate this part will be 2 over a multiplied by sin inverse ax over a. The last answer will be s to the power of 2 sin inverse ax over a minus 2 sin inverse ax over a to the power of 2 plus c constant. Okay, next we will be using tabular method. So the question is integral x to the power of 2 cos inverse ax dx and less than or equal to 2. Okay, so we'll be using tabular method. So we have alternative signs. U and its derivative and V and its anti-derivative. positive, and so on. So the u, we will take x to the power of 2 as u, so x2, if we after we differentiate, we will get 2x, and this we will get to 0. Okay, you should be derivative until you get 0. Then cos ax, this here will be negative sine 1ax over a, then cos negative 1ax over a multiplied by a, and plus sin ax a multiplied by a multiplied by a. So it should be this x to the power of 2 will be connected to sin inverse ax. This will be here, and this will be here. Okay, so the answer will be negative sine inverse 1ax multiplied by x to the power of 2 over a plus 2x cos inverse 1ax over a to the power of 2 plus sine inverse 1ax over a to the power of 3 plus c should be constant. That's all for me. Thank you.
Here, what we have is integrate exponential function. So here is the list of integrate exponential function. So everything about integrate that have no range, we have to plus it with c. So let's take a look at the first one. Integral e to the power of x dx will become e to the power of x plus c. And number 2 is integral e to the power of x dx will become e to the power of ax plus c. And the third one is integral e to the power of ax plus b dx will become 1 over a e to the power of ax plus b. Let's take a look at the next one. The next one is integral a to the power of x with respect of x equal a to the power of x divided by ln a plus c. The second one is integral a to the power of x ln a dx will become a to the power of x plus c. So let's take a look at our question. So we got a question, integral x to the power of n a to the power of bx with respect of x, and our n is smaller than 2 or equal to 2. A basic formula where integral u dv equals to uv minus integral v du. So we're gonna find each of it. We're gonna find everything that have in the formula. So let u be x squared, where our n is 2, and then we find the du dx is 2x. So our du is 2x dx. So we're gonna find the next one is dv dx is a to the power of bx. So our dv is a to the power of bx dx. And our v is, we have to put abx divided by b ln a. We use the integral exponential function. So we have all of this. We have our u, our du, our dv, and our v. So we're going to substitute all of these inside the formula. So let's start. Integral, our u is x to the power of 2. Our dv is e to the power of bx dx. So another one equals to our u is x to the power of 2. Our dv is e to the power of bx dx. So another one equals to our u is x to the power of 2. Our v is a to the power of bx equals by b ln a. So we continue it. We just put our x to the power of 2, a bx divided by b ln a minus by, so we have to multiply it. It will become 2x divided by b ln a times a bx divided by b ln e. And we continue it. X to the power of 2 a bx divided by b minus, and then we have to multiply it again. It will become 2x a bx divided by b ln a. So the answer is equal to x to the power of 2a bx divided by b ln a minus by, we have to multiply it. So when we multiply it, it will become 2x a to the power of bx divided by b ln a to the power of 2. So we have to plus it with c. Our c is constant. So that's all.